Now start entropy and information gain. What exactly entropy and information interesting, and this topic is mainly involved in machine learning algorithms like this random forest, for you to know to be really work and why this is so essential in building machine learning models, which focus on the statistic parts of information gain and entropy. After that, we'll discuss a use case and see how information gain and entropy is used in decision trees. For those who don't know what a decision tree is, it is basically a machine learning algorithm. You don't have to know anything about this. I'll explain everything in depth. So don't worry. Let's look at what exactly information gain is. As entropy is basically the measure of any sort of uncertainty present in the data can be measured by using this formula. So your S is the set of all instances in the dataset or all the data items in the dataset. N is the different type of classes in our dataset. API is the event probability. This might seem a little confusing to y'all, but when we go through the use case, you will understand all of these terms. Even better, right? Coming to information gain. As the word suggests, information indicates how information a particular feature, or a particular variable gives us about the final outcome. It can be measured by using this formula. Again, her heads of S is the entropy of the whole data set. SSJ is the number of instances where the G value of an attribute. S is the total instances in the data set. V is the set of distinct values of an attribute. A hatch of Sj is the entropy of subset of instances, and is the entropy of an attribute. Even though this seems confusing, I'll clear up the confusion. Alright, let's discuss a small problem statement where we'll understand how information gain and entropy is used to study the significance of a model. Like I said, information gain and entropy are very important statistical measures that let us understand the significance of the model. Okay, to get a more clear understanding, let's look at a use case. Now suppose we are given a problem statement. Alright. The statement is that whether a match be played or not by studying the weather conditions, the predictor variable or outlook human, there is also a political will is basically play right. The target variable is the variable that you're trying to predict. Okay, value the target variable will decide whether or not a game can be played. So by the end, yes, meaning that the weather conditions are not good and therefore you cannot play the game. Yes, meaning that the weather conditions are good and suitable for you to play the game. Alright, so that was a problem statement. I hope the problem statement is go to overview how to solve the problem. We make use of something known as decision trees. An inverted tree in each branch of the tree denotes some decision, right? Each branch is known as a branch, and at each branch know you're gonna make a decision. In such a manner that you will branch. Now this figure basically shows that out of 14 observations, 9 observations result in a yes, meaning that out of 14 days, the match can be played only on 9 days. Alright. So yeah, if you see on day 1, day to day 8, day 9, and day 11, outlook has been sunny. Sunny. So basically, depending on the outlook, when the outlook is sunny, this is our data set. When the outlook is overcast, this is what we have, and when the outlook is green, this is what we have. So when it is sunny, we have 2 yes. And 3 no's. Okay, when the outlook is overcast, we have all 4 as yes, meaning that on the 4 days when the outlook was overcast, we can play the game right now when it comes to rain. We have 3 s's, and if you notice your vision is being choosing the outlook variable as the root node. Okay, so the root node is basically the topmost node in a decision tree. Now what we've done here is we've created a decision tree that starts with the outlook node, right? Then you're splitting the decision tree further, depending on meters like sunny, overcast and rainy. Right now, like we know that outlook has 3 values, sunny, overcast and rain. Let me explain this in a more in-depth manner. Okay, so what you're doing here is you're making the decision tree by choosing the outlook variable node. Root node is basically the topmost node in a decision tree. The outlook node has 3 branches coming out from it, which is sunny, overcast and rainy. So, outlook can have 3 values. Either it can be sunny, it can be overcast, or it can be rainy. Now these 3 values are assigned digit branch nodes, and for each of these values the possibility of play is equal to yes is calculated. So this Annie and the rain branches will give you an impure output, meaning that there is a mix of yes and no, right? There are 2 yes, your 3 no's here, there are 3 yes, your and 2 no's over here. But when it comes to the overcast variable, it results in 100% pure subset. Alright, this shows that the overcast variable will result in a definite and certain output. This is exactly what entropy is used to measure. Alright, it calculates the impurity or the uncertainty. Alright, so the lesser the uncertainty or the entropy of a variable, more significant is that variable. So, when it comes to overcast, there's literally no impurity in the data set, it is 100% pure subset, right? So, we want variables like these in order to build a model. Alright, we don't always get lucky, and we don't always find variables that will result in pure subsets. That's why we have the measure entropy. So, the lesser the entropy of a particular variable, the most significant that variable will be. So in a decision tree, the root node is assigned the best attributes so that the decision tree can predict the most precise outcome, meaning that on the root node, you should have the most significant variables in Outlook. Or you might be really. Do you choose an overcast? Now guys, overcast is not a variable, it has a value of the Outlook variable on it. That's why we chose to cure, because it has 100% pure subset, which is overcome entropy. So the lesser the entropy of a particular variable, the most significant that variable will be. Decision tree, the root node is assigned the best attributes so that the decision tree can predict the most precise outcome. That on the root node, you should have the most significant variable. Alright, that's why we've chosen Outlook. And now some of you might ask, my chosen overcast, whereas overcast is not very well, it is a value of the Outlook variable. Alright, that's why we've chosen Outlook here, because it is 100% or subset, which is overcast, right? Now, the question in your head is, how do I decide which variable or attribute best splits the data? Right now I know I looked at the data, and I told you that here we have 100% pure subset. What if it's a more complex problem and you're not able to understand which variable, but best split the data? So guys, when it comes to decision trees, information gain and entropy will help you understand which variable will best split the data set or which variable you to assign to the root node. Because whichever variable is assigned to the root node, it will best read the data has to be the most significant variable. Alright, so how we can do this is we need to use information gain and entropy from the total of the 49 of them said yes, and the incensus said no, you cannot play on that particular day. So how do you calculate the entropy? So this is the formula, your values in the formula, so when you substitute the values in the formula you will get a value of 0.940. Alright, this is the trophy, or this is the uncertainty of the data present in our sample. Now, in order to ensure that we choose the best variable for the root node, let us look at all the possible combinations used on the root node, okay. So, these are all the possible solutions. You can have Outlook, you can print the humidity or temperature, okay, these are 4 variables, and you can have any one of these as your root node. How do you select which way will fit what we are going to see? By using information gain and entropy. So guys, now the task at hand is to find the information gain for each of these attributes, right? So look for windy for humidity, temperature, we're going to find out the information gain, right? And to remember is that the variable that results in the highest information gain chosen, because it will give us the most precise and output information, right? So the information gain for attribute windy will calculate that first. Here we have 6 instances of true and 8 instances of false, okay. So when you substitute all the values in the formula, we'll get a value of 0.048. So we get a value of 0.04. Now this is a very low value estimation game. So the information that you're going to get from windy attribute is pretty. Let's calculate the information gain of attribute Outlook. So from the total of 14 instances we have 5 instances with say sunny, 4 instances which are overcast and 5 instances which are rainy, right? Sunny we have 3 yes and 2 no's, overcast we have all the 4 as yes. Could we have 3 yes and who knows? Okay, so when you calculate the information gain, Outlook variable is 0.247. Now compare this to the information gain of the windy attribute. This value is actually pretty good. Right, we have 0.247 is a pretty good value for information gain. Now let's look at the information gain of attributes. Under the high branch note we have instances with say yes, say no. Similarly under number 2, we have 1, 2, 3, 4, 5, 6, 7 instances, say yes and one instance where it says no, right? When you calculate the information gain for the humidity variable, you're going to get a value of 0.151. Now this is also a pretty decent value. But when you compare it to the information gain of the attribute is less. Right. Now let's look at one of attributes temperature, so the temperature can hold repeat temperature hold hot, mild and cold. The hot we have 2 instances with says yes and 2 instances for no. The mild we have instances of yes and 2 instances of no, and under cold we have 3 instances of yes, and when you capture information gauge's attribute you will get a value of 0.029, which again very less. So what you can arise from here is if you look at the interest for each of these variables, we'll see that for that we have 0.247 which is highest, and you must always choose a variable highest infamy. Let the data at the root node be assigned the outlook variable at the root node. Right. So guys, I hope this use case was clear. If any of you have doubts, now let's move on and look at what exactly a confusion matrix is. A confusion matrix is the last topic for descriptive statistics. Right after this, I'll be running a short demo where I'll be showing you how you can calculate mean, median, mode and variance, and using R. Okay, so let's talk about confusion matrix. Now guys, what a confusion matrix is this is not any complex topic. Confusion is a matrix that is often used to derive the performance of a model, right, and this is specifically used for classification models or a classifier. And what it does is it will calculate the accuracy, or it will calculate the performance of your classifier by comparing your actual results and your predicted results. So this looks like true positive, true negative, and all of that a little confusing. I'll get back to what exactly true positive, true negative, and all of this stands for. Now let's look at an example, and let's try and understand what exactly a confusion matrix is. Guys, I made sure that I put examples after each and every toy, but important to understand the practical part of the 6 has literally nothing to do with theory. You need to understand how calculations are done in statistics. So here what I've done is, let's look at a small unit. Let's consider that you're given data about 165 patients, out of which 105 patients have a disease. Patients don't do it will fire that by using these 165 observations. Feed all of these 165 observations to your classifier, and it will predict the output every time a new patient's detail is fed to the classifier, right? Out of these 165 cases that say that the classifier predicted yes 110 times and number 55 times. Alright. Yes basically stands for yes. And has a disease, and no stands for no, the person does not have a disease. Right. That's pretty self-explanatory. But yeah, so it predicted that 110 times patient has a disease and 55 times that no, the patient doesn't have a disease. However, in reality, only 105 patients in the sample have the disease and 60 patients who do not have the disease. So how do you calculate the accuracy of your model? You basically build the confusion matrix, right? This is how the matrix looks like. Basically the nodes, the total number of observations that you have, which is 165. In our case, actually the nodes are the actual values in the data set. And predicted denotes the predicted values by the classifier. The actual value is no your and the predicted value is no here. Your classifier was correctly able to classify 50 kills. No. Right. Since both of these are no, so 50 it was it. Correctly able to class but 10 of the class. You're sure isn't, but you predicted. Yes. That's why they dropped me wrongly that 5 pins not have these. This and it correctly predicted 100 patients which had the disease. Red Angus is a little bit confusing, but if you look at these values, no number 50 meaning that it actually corrected 50 values. No yes means that it wrongly predicted yes for the values that it was supposed to predict no. Right. Now what exactly is this true positive to negative and all of that? I'll tell you what exactly it is. Positive are the cases in which we predicted a yes. And they do not actually have the disease. Alright. So it is basically this value that we predicted a yes here, even though they did not have the disease. We have 10 true positives. Similarly, true negative is we predicted no, and they don't have the disease mean that this is correct. Predicted deaths, but they are also known as type 1 error. False negative is we actually do not have the disease. Guys, basically. And true negatives are basically correct classifications, alright. But this was confusion matrix. And I hope this concept is clear. Again guys, if you have doubts, please comment your doubts in the comment section. So guys, that was descriptive statistics.